Okay, so remember in 7.1, we learned about discounts and sales tax. Discounts you subtract from the original price. Sales tax, you have to add it on to the original price. But you're always working with a percentage. So just remember, you have to turn that percentage to a decimal, and then you're multiplying it times whatever that like original price was. So kind of the same first step, but second step, depending on if it's a discount or a sales tax, what you do next. I did tell you at the end of class the other day that I wanted to talk to you a little bit about time. And so I am going to go ahead and do that now. So if you've started your homework and you're like, what is this? Because there's a first question that says, what would time be if we were talking about, say 7 out of 12 months? If I said 7 months, right? So if you said 7 months, your time period would be like 7 out of 12 if we were talking about months. If you did, if it was 3 months, I think WebAssign would take 3/12. I don't think you have to reduce it, but really that first question I think is multiple choice anyways. So you would just see what it is and click that right one. Because remember, when we're talking about simple interest, your principal times your rate times your time is always understood that they're thinking about annually, even though some things they will say month, like is paid back in 6 months. Like maybe they just do a loan for half a year or something like that. Now, banker's rule is something we don't have in these notes. I have them in my other notes that I used to use. But banker's rule says that there's only 360 days in a year. And so here's the really fun part about this unit. Sometimes when we think about a year, we are going to think 365 days. And then sometimes we're going to think 360 days. And if you're unsure, just try one. And if it's wrong, try the other. That's what I would say. But for the most part, like when we get to talking about compound interest, that one's going to be 365. Okay. When we're talking about simple interest, it's 360. Make sense? Have you guys seen a question like that yet? Doing it yet? No? Yes, no. It is kind of weird. I don't know why we sometimes use banker's rule and sometimes don't. I can understand why we don't when we're talking about compound interest, because those 5 days tack on more interest when you learn that. I mean, that makes a little bit more sense. But the 360, when we're talking about simple interest, really could kind of almost be converted into, I don't know, months or whatever. But I believe the reason they do that is banker's rule, there's 12 months out of the year, right? And then they just average every month to be 30 days. So that's where they get the 360 days for your banker's rule. So sometimes you're going to have to think 360 and not 365. Okay. So I did want to just touch on that briefly. But remember, sometimes you're finding other things, like you may be able to go just and find the interest. So you would be just multiplying these things together like we did in the last class meeting to get this value. Otherwise, you may have to do a little algebra to solve the part that's missing. So I'm not reteaching all of that. There is that lecture if you missed it or if you need to see it again. We are going to talk about buying on credit today. So it says a blank is an agreement to pay off a loan or a purchase by making equal payments at regular intervals for some specific period of time. So that would be like monthly payment. Remember when we did a problem in the last lecture about monthly payments? So we said, yeah, you're going to pay $58 per month. You can figure out how much you would pay in the end by knowing the payment amount. So this is called just an installment loan, or you could just say loan, but the technical terminology is installment loan. You don't really have to memorize. I put loan. You don't really have to memorize vocab words or anything. Just be familiar. That's just a loan. Okay. We've kind of already talked about that a little bit. So the loan is said to be, and the word is amortized. It's AMORTIZED. I like to say paid off. That's really all that means. The loan is said to be amortized if it's completely paid off by these payments, and the payments are called installments. So sometimes they call them installments and not monthly payments. So you just need to know that terminology can be a little bit different. They use different words to mean the same thing often. Yay for the English language. That's what we get for our English language. So add-on interest is really just what you already been doing. It is using your simple interest formula and adding it onto the top of your principal, because that tells you how much you would have paid by the end of the loan. Do you see how this feels a little bit like a repeat, right? It's just another word, add-on interest, okay? Some things to know about letters, and we've already kind of seen some of them, is your present value, or remember, a lot of times you think of it as principal. The amount to be financed is the letter P. Your R is your rate. T is your time, still in years. So if they give you months, you have to make it a fraction. If they give you days, you have to make it a fraction out of 360 days. And then I is your interest. So that goes right back to this formula right here. Future value. I like to use FV because then we know that that's the first letters of the words, but technically you're going to see it as the letter A sometimes. So just kind of try to remember that. And future value is when you add your principal and interest together. Your monthly payments. So if you are paying something out for 3 years, all you have to do is take 3 times 12 to find out how many monthly payments you get. So sometimes they represent that with the letter M, which is right here. And we can find the number of payments by what I just said. 12 times however many years it would be, okay? So it's just a fancy way of saying some of the things we've already done before today. We just actually have it written out with the letters beside it now. So sometimes you might already know, like say I know by the end of the loan, I'm paying $898. Maybe you don't know what your monthly payment would be. So you would take that future value, what you would pay by the end of the loan, and divide it by the number of payments you'd be making. Like say you're doing that for 3 years, so 36 payments, right? So again, I kind of really stressed to you last class period, let's try not to get bogged down with too many formulas, because that's what these are, and just think about how it applies. And I think you would naturally do those things without being stuck to a formula, like which formula do I use? Okay, so let's turn the page and start talking about finding the interest and monthly payment on some problems here. So the first thing you would need to do is sometimes calculate the interest. You know, every problem might be given to you a little bit differently, but as a starting point, we're going to calculate the interest, right, by using your simple interest formula. We're going to have to know the future value. So remember, your future value would be just adding that principal and interest amount that you just found in the step before. And then you're going to calculate the monthly payments. You're going to take that future value and divide it by number of payments. I'm going to write it like that instead of the other way. The number of payments you made, and then that can tell you how to find the monthly payment amount. Maybe it's not given to you, and that is what we want to find. So let's look at number 1. It says, if you have a loan for $2,500 at 8% add-on rate for 3 years. They're wanting you to find the interest and monthly payment. That's what the instructions are up here. So usually I put the instructions with each problem, but it's all up top. We're going to do the same thing on these 2 problems together. So the first thing we have to do is find the interest, like we just said. So step 1. Let's go ahead and identify what each part is though first for our notes. So for our principal amount, isn't that the $2,500? That's the amount you're getting a loan for. Your rate is 8%. But remember, we can't use it as 8% when we do stuff. We have to divide it by 100 or slide to the left 2 places and use 0.08. Your time Period is 3 years. So if I'm doing the first thing it asks me to do, step 1, don't really know why I have a circle there. Step 1, calculate the interest. We could do that, right? We could say 2,500 times 0.08 times our 3 years. 2,500 times 0.08 times 3 years means the interest amount would be $600. So I went and found from this given information that my interest was $600, right? Well, my second thing that they want us to do up here in these instructions is find the future value. So now that we know the interest, and now that we know our principal, I'm just adding those together to 2,500, plus 600. So the future value, or you could put the letter A by there, was what, $3,100? So we have to be able to find the interest to find the future value, so we can find what would the monthly payments be if you paid that out for 3 years. Well, the third thing that we would do is go find the monthly payment. And so you're kind of building that over here. So how many payments am I going to make if I'm paying that out for 3 years? Yeah, we would take 12 months times that 3 years. So that would be 36. You could have maybe already done that in the beginning, knowing you're going to have to figure out how many payments you make. So this is number of payments. If you don't like seeing the letter N, means I'm going to make 36 payments. So you're going to put your future value, meaning what you paid total by the end of the loan. And that's the amount, the loan amount plus your interest. And we're going to divide it by 36 payments. And that's going to tell us how much the monthly payment would be. So 3,100 divided by 36. Sometimes it's not going to be an ending number, but we'll round to the nearest cent, which means 2 digits, right? So this would be 8611. That would be our monthly payment. So we found the interest, which helps us find the future value, so we can go find the monthly payment. So kind of going backwards, remember when we did lecture 7.2, I said, if you are given a monthly payment, could you find the future value? And we did kind of the same thing. We just didn't divide, we multiplied. If I know I'm going to make 36 payments at this amount, if I'm working backwards, like we did in 7.2, I'm just showing you that it's the inverse operation. I would have multiplied times the 36 payments. Now, that's not exactly $3,100, right? Because we rounded. That shows you where rounding changes stuff, and especially in money, that's like 4 pennies. At some point, they're gonna put those 4 pennies in there for you, but usually it's like on your first payment, might be a different little amount, but it does make a little bit difference. So just kind of showing you that back in 7.2, we did it. We just did it in a different way. We were given the monthly payment amount. And then we thought, if I'm paying that for 3 years, I'd have to make 36 of those payments, which is what we figured out here. So I'd multiply to get the future value. But now we know the future value, and I want to distribute that across 36 payments. I don't want to pay it all at once, right? That's why you get a loan, to make smaller payments at once. So I'm going to divide that between 36 even payments. And you would get 8611 when you do that. Does that make sense? Okay, so let's go do another one. So we're going to purchase a couch for $900. The rate is at 11%. And we're going to do that for 2 years. So I like to just pull the given information out. Sometimes I just put it above what we have, but I'll go ahead and write it. So my principal is $900. My rate is 11%. So that would be like saying 0.11, right? So I'd slide it to the left 2 places. My time is 2 years. So I can go find my interest, my step one that we have up there above, by taking my principal, which is $900, times my rate, times my time. And that will give the amount of interest it would cost you on that loan. So that would be $198. That's going to be an added cost to you to borrow $900, almost $200 more. So we find that because to be able to go find the actual monthly payment, they ask you to find the interest, which we did. This is one of our answers. But to be able to go find the monthly payment, we have to find future value. We have to think, I'll write the word future value too. We have to think, I'm going to take the amount of the initial loan and I'm going to add the interest amount to it. So that means over the 2-year time period, I paid $1,098. So they don't really ask you to find that, but you have to find that to be able to find your monthly payment. You have to know how much would you have paid in the total in to then go from there. So if I'm paying it for 2 years, the number of payments, which is usually the letter N that we see, I'd be taking 12 times 2 years, right? So we'd have 24 payments. So you need to know that. That's where the 24K comes from. That tells me how many, but to find the monthly payment, I take my future value, which is the 1,098, and divide it by 24, which is 45.75. So that's an ending one. So that one would be perfect if I were to go backwards and say, well, I know I'm going to pay 45.75 for 2 years. I'm going to make 24 payments. 45.75 times 24 is that amount that we said we would have paid with the interest added on top. And so that's real life stuff. I don't think I've said this, but maybe you've already kind of noticed higher interest rates mean you higher interest amounts, right? 11% interest is actually a pretty big interest rate. Credit cards sometimes go up to like 21% interest, which is huge. And that stuff adds up fast and it starts to snowball, which we'll start to learn about when we talk about compound interest. And the nice thing about simple interest is it's like a one-time fee. Okay, it's not snowballing on you. It's a one-time fee. And so in the end, you would already know how much interest you owe. So that's why it's important if you get a loan to know how your interest is figured. So you know how much interest you would be paying in the end too. But you're always going to know your monthly payment amount, right? When you go buy something. So then you should take calculation from what we just did backwards and be like, I'm paying this off for 5 years. How much am I paying in the end? And you could figure that just like we talked about in the last section. So annual, which is like an actual percentage rate. So this is a rate that you pay on a loan when the rate is based on the actual amount that you owe for the length of the time it's owed. So that probably is a little confusing. How do we have two different kinds of rates? This is a different kind of rate. Sometimes when you borrow money, there's other costs that they figure into your loan, and it's not like your principal amount. So like if you have a processing fee to buy something, that's an added cost that's going into your loan. And in a sense, that's driving your rate up, which kind of seems weird. It seems like it's two different things, but that's tied together. If you buy a car and if they have a docking fee, a lot of them do, they start to add extra fees on top of the extra actual purchase of your car. If you've ever done that, it might be $500. So that amount is actually being figured into your rate. So when you are buying vehicle. I think sometimes it happens with that. It does happen a lot with credit cards. That is your annual or your actual percentage rate. So this is a yearly rate as well. And right now, we're really just talking about a rate. And so if you want to write that down, this would be the rate paid on a loan when the rate is based on the actual amount owed for the length of the time it's owed. So when we start talking a little bit more deep in business, you'll find that your simple interest rate really isn't what's usually happening. So an APR is generally just a little bit higher than like what you would think your simple interest rate is, because it's an additional amount. It's going to be a little bit bigger. So you'll be given like your standard rate. Say you're told that something is a 13%. But they actually use an APR, meaning there's other fees that's coming into it. There's a formula that you do have to know how to use that figures that standard rate that will apply to everything else, and it will be the full real rate of your loan. It's kind of weird. You have a rate and then you have another rate. Okay, so find the APR. It says you're going to purchase a computer for $2,200 at 13% add-on rate for 2 years. I'm only finding the APR. So when we're finding the APR, the only thing you need to know is number of payments. You just need to know two things: number of payments and the first rate, like your little rate. Right? So kind of like sometimes it's the advertised rate. Technically, they're supposed to inform. That's why they tell you if it's an APR or not. So it's not really that, 3% APR rate. So it's actually end up being a little bit higher if they're using an APR to figure in other additional costs to purchase your whatever it is you're purchasing. So all we really need to know is this. And we need to know, we kind of need to use this 2 years because we need to know number of payments, but we have to convert it, right? I'm going to write the word years right here since it's down over here. So we kind of need to know this, but we need to convert this to number of payments. So I'm going to say 12 months times 2 years, right? So we have 24 payments that you would make on this one. So that's going to be your in amount. So your rate amount was given 13%, so 0.13. These are the only two things you need to know to find what the actual APR is. It doesn't matter what you're purchasing or for how much. So we're going to say my APR, I put AR, let's pretend this is a P. APR is 2 times the number of payments, which is 24, times my rate, I said is 0.13, all over my number of payments of 24 plus 1. So there's always a plus 1 and there's always a 2 in that formula. And where you see the N's, you plug in those number of payments. Where you see the R, you plug in the rate. And I would say I set it up just like this in my calculator, like a fraction, just so I don't mess up like an order of operation of sorts. So 2 times 24 times 0.13 divided by 24 plus 1. I know you could just write 25, but I'm just going to type it exactly like I see. And so this would be like saying 0.2496. So this is an actual rate. So what do you think we have to do to this if this is a rate, which is a percentage? What do we need to do to this? Should we convert it? Think about how that works with the percentages. Sometimes we convert a percent when we're using it in calculations. We move that decimal to the left 2 places, right? But there are times, if you remember, where we had to find rate, and rate when you're doing calculations is represented as a decimal. So from here, we need to turn it into a percentage so it represents an actual rate. So we need to multiply it times 100 or slide to the right 2 places, whichever one you're accustomed to doing. So since that was an ending one, we don't have to like round it. We can keep it as 24.96%. So the APR would be 24.96%. If WebAssign tells you to round to the nearest whole number, just write all those numbers out so you'll see that 9 and know that it would be like 25%, right? If WebAssign tells you to round to the nearest 1/10 of a percent, then write all those numbers out so you'll know which one. So maybe make sure you're writing those decimals out a little bit further. And that's something we'll have to talk about a lot in this unit. When it tells you to round, we don't really want to round until the very end. So you always want to leave those decimals with like 4 or 5 numbers after until the very last step of rounding, because those things make a little bit of a difference. Remember whenever I plugged in my calculator and we had changed that amount a little bit by rounding because of the 11 cents. Go back to about 10 minutes ago. That does change it, right? Just a little bit. So that's why you need to use as many decimals as possible during the calculations. But this one, it didn't matter because that was the end and we finished it out. Number 4 says find the APR. So again, it tells us the amount of a loan. We don't care about how much the loan is. All we care is that they tell us a percentage rate. And if it's 3 years, that means I need to convert that into number of payments by taking 12 times 3, which means we have 36 payments. My rate would be 0.095. So our APR for this particular problem, we still take the 2 from the formula times the number of payments. This one was 36 payments times my rate, and my rate is 0.095 all over 36 plus 1. 2 times 36 times 0.095, and 36 plus 1 is this 0.18486. I just wrote like 5 numbers down, which is kind of my habit. A lot of times they'll tell you either 1 decimal or 2. I'm going to take it to 2 because I think that's my habit of doing. So if I were to slide that to the right 2 places, or take it times 100% to turn it into a percentage, since this is a rate, this would be like saying 18.486. But if I were practicing my rounding skills and saying, let's round that to the nearest 100th or 2 digits, what would the 8 be? Would it stay an 8 or would we round it up? We round it up. Good job. Pretty close. Probably one like that, it'd make a lot more sense to us to just say 18.5%, right? So just pay attention to the rounding instructions. Seems like this unit does have, I have to go look. Always need to write these down. I write it down sometimes. Sometimes you do have to answer as an ugly fraction, but I don't think you would one like that. I hope not. WebAssign needs to listen to me and take my advice on the, like, let's not answer those things sometimes in fractions that don't make applicable sense. But technically you can always turn things into mixed numbers, so those would be fine. But the others, I don't really quite understand why we do that. There's probably purpose. Okay, so let's do something where maybe we have to think a little bit more, do some other things, an application problem. It says a newspaper advertisement offers $4,000, a $4,000 used car for nothing down and 36 easy monthly payments of $141.62. What's the total amount paid for both car and financing? So can we figure out how much we pay in the end if we know monthly payments? Yes, and it says that we're doing it 36 easy payments. So they kind of give us the amount of payments that we're making. I'm just gonna write this down. Monthly payment was 141.62. They say we make 36 payments. I can find out the total amount paid by doing what? Just multiplying those things together. My future value, I would take 141.62 times 36 payments. Oops. So we would have paid $5,098.32. That's total paid. That's what future value means. What if I were to ask you how much interest? It doesn't ask you that, but a lot of times you have to know that. How much interest paid?
4,000.
Right. We take that future value and we subtract. We really were bought this. They tell us was how much what we were gonna how much the car cost, right? 4,000. It's up here. That was the initial purchase. So what is that? $1,098.32 would be the interest that you paid. So a lot of times you're going to find not every question is exactly like what you see in my notes, but I try to go back and forth to show you all the different things that could be unknown in a problem. And that's why sometimes we do extra things as well. So number 6 says, find the APR for the problem above. So remember my APR, I need to know number of payments, and I can find if it's 3 years. Wasn't that, or sorry, I went backwards. It's 36 payments, right? So I already knew that. 36 payments. My rate is something that I don't know. So we have to do a little bit more work. And that's where my 3 years just came from. We may need to turn how many payments that we had back into years, because we have to go back and use our simple interest formula. So this is where APR gets a little bit hard. I say hard, but remember, when we're finding APR, that's our 2 times N times R, and then your N plus 1. They don't tell us the interest amount in that problem, do they? So unfortunately, that means we're going to have to go find R. That's what we don't know. Because we know the number of payments already. So we have to go find that. So let's go think about what we do know. What we do know is my interest amount is what I found already, is $1,098.32. My principal was how much? How much did we originally purchase the car for? 4,000. They don't say, like, well, they do. They say this is what it offers that car for it. That's what they purchased it for, was $4,000. We don't know the rate, that baseline rate that we need for APR. But we do know the time, and that's where my 3 years came from. If you know that there's 36 payments, then you just divide that by 12, and that tells you it's for 3 years, right? So we have to use 3 years. We can't use 36 because that's gonna simple interest calculates that like it's 36 years, not 36 payments. So we have to go back into our yearly mode. So you sometimes have to convert payments back into years. So we're going to go find our rate. That was something we learned in 7.2. It's been a little bit, but hopefully you've done that homework. So $1,098.32 equals my principal times my rate times my time. Remember, this is using your simple interest formula. What do I do first before I can solve for R? Multiply. We got 4,000 and 3 that needs to be multiplied. So 1098.32 equals 4,000 times 3 is 12,000, and then we could put the R on the end. Now what do we get to do to get R by itself? Divide. Divide by 12,000. Bless you. So here we go. In our calculator, you can set up as a fraction or hit divide. So we have 0.091. I'm going to take it to 4. You could take it to 3 if you want. 5. You need to at least do 4. This is where I'm coming from when I say don't round. If they give you rounding instructions on this one, don't round right here. Take this number a little bit further because I'm going to use this in another calculation, okay? I'm putting that in my APR formula, and if we round it, it's going to change the number slightly and you'll get it wrong. And it happens all the time. So take this one, since it's not your final answer, I have to go find this rate 0.0915, because to go find my APR, I now know it, right? Now I can use that in that formula. So I had to go do all that work to find that. Bless you. So we're going to take 2 times, how many payments did we make in this one? 36 times our rate that we just found. That's what all we had to do all that work for. So it's kind of pulling 7.2 in with this 7.3 stuff. And then we're going to divide by 36 plus 1, or you could just write 37. Oh, I did that right. So here, APR, if I were to write 0.178, maybe 0.5, don't really have to. If I were to say round to 1 digit, you would first take it times 100%, because we're rounding the percentage in the very, very end. So that means you're sliding to the right 2 places, 1, 2. And if I say round to the nearest 10th, that means just 1 digit. Wouldn't I just keep 8 the same and drop the others off? So APR equals 17.8%. So that's really different than if you're looking at a 9% interest, right? Whenever the base rate is 9%, but if they're using APR in their charging you for your interest or whatever, then really it's accumulating and costing you more than what it initially looks like because of all the other added fees that are going on to buying that, whatever it is that you buy. So technically you're paying a 17% interest rate for all those other fees that pays that bank. That's how banks make their money. They have fees for printing a piece of paper, that's just, they make a killing. We're charging for all those things. So APR can get a little bit busy. So initially APR looked really easy, right? And it is, if you understand, you just need number of payments and rates, but sometimes we're going to have to think outside the box. We have a lot of given things. We have some unknowns that we're going to need to find to be able to go find our APR in the end. All right, let's turn the page and we're going to talk a little bit about credit card interest. We're not going to get all the way through this lecture probably, but maybe a bit through it. So 7.3 is its own homework. I don't think we'll get through 7.4 like I said, so it won't be due until like Thursday of next week, but probably it will be due with your 7.5. So, but your 7.3 will be due Tuesday. Okay, so credit cards advertise their interest rate as a monthly rate. So they don't say, over the whole year, here's what you're doing. It's per month an interest rate that's happening. That's what the difference is between APR. That's representing your annual rate. Okay, so that's thinking of the whole year. Credit cards are thinking about 1 month at a time. Sometimes they do daily rates too. And you can kind of see those percentages, just for example, like 1.5% monthly rate. I will zoom in just a little bit more for my zoomers. Okay. So this would be great. That 1.5% would be great if it was per year. But that's where you need to find the APR. What would that cost you if you use that card for something over the entire year when they say, okay, for 12 months, you're going to pay for that. And they're saying it's 1.5%, but it's really not, because each month it's going to add on to your bill as interest. Okay. So by the end of that, you would find what it really would be by using APR. So let's go do that with this. So if a credit card tells you you have a rate of 1.5%, and that is per month, we are really just going to have to say 1.5% times 12 in this case. Because you have 12 years, you don't have to go back to the formula. You just say 1.5% times 12, and actually you could keep it even as a decimal, since you're not converting it otherwise. Otherwise, you'd have to convert it back, right? Because you're wanting to represent it as a percent. So this would be like 18% per year. So 18% APR, which is really like your per year. That's really what you would be paying. And let's say you use a credit card and to buy something rather than go get an initial loan, right? Those initial loans, they actually are required to advertise that more, like it's advertised yearly. So you would know if you're paying 18%, but a credit card, it's a little bit hidden and deceptive. So if you're buying something for $900 on a credit card, you're not really paying 1.5% only. You're actually paying that over, you're doing it 12 times. So 1.5% times 12 would be 18%. So to convert like a credit card interest rate, all we have to do is take it times 12 months. And that shows you what the APR is. If we're looking at this daily rate, it looks really small, doesn't it? So a decimal, we can take the actual digits that you have and take it times, in this case, because it's credit cards, they don't use Banker's rule. We take it times 365 days. Daily, monthly, that's the difference, okay? So we're gonna go 0.04872%. We don't have to change it to a percent or anything. It is a percent, we don't have to change it. Times 365 days means you're really paying, let's call that 17. I'm not going to write it down because I didn't write space, but let's round it to one digit. Let's call that 17.8. Okay, we're going to round it to one digit. Wouldn't that be an 8? Round the 7 up to an 8. So 17.8%. So if they're advertising the daily rate, it looks like really small, like it won't even matter. But if you pay that thing out, if you use the recommended lowest payment that you're supposed to make on your credit card, by the end of that loan, you would have actually paid, by the end of that year, if you pay it off, you would have actually paid 17, almost 18% on that purchase. So credit cards can really ruin your life. Remember when I told you I wish I would have been taught some of this when I was between 18 and 25? That was my thing. Some credit cards caught up with me. So I don't even have them now because, well, I do for certain purchases, but I pay them off that very month because I don't want to get caught in that again. Okay, so let's go back to some things that we already know that still kind of applies as we go through much of this unit. Our simple interest rate. So credit cards are figured on 3 different methods. The previous balance method. So this means you're not going to take into account any payment made. So whatever your balance is on your account, that's what you're going to use as your principal. we talk about an adjusted balance method. So means we're probably going to subtract a payment that we make and then use that as the principal in our simple interest formula. And then we have an average daily balance. So we're going to always assume that the month is 30 days long. It's just an average of all months. And in WebAssign, they say, we're going to assume that for 10 days, you're at the previous amount. And the other 20, we're going to adjust it. So that one's a little bit more to do for your principal. But let's talk about the first two, and then we'll talk about average daily on Tuesday of next week, okay? First two, I think you'll get pretty good. So when we're talking about previous balance method, so interest is calculated on the previous month's balance. So we don't make, if they tell you a payment's made, we don't care about it. So it says calculate interest on an $800 credit card bill that shows 19% APR using the previous balance method. Assume that $30 is sent and recorded by the due date. But since it's a previous balance, we don't care. We don't care that they sent in $300 or $30. $300 is what I'm about to say. But we know that the principal amount, meaning your balance on your credit card, is now considered your principal. They tell us the rate is 19%. So you do use the APR rate because it's credit cards. So that's your rate that you're plugging into your simple interest, or your simple interest formula. That's 0.19. Now our time though in credit cards is always going to be 1 out of 12 because it's monthly. So to figure the interest that would be calculated on that bill, we would take 800 times 0.19 times 1 out of 12, or 1 over 12. So if you have this calculator that does fractions for you, which I think everybody does now, you can just type it in just like you see and click enter. And so if we were rounding that, we would need to round that last 6 up to 7, right? So $12.67 would be the amount of interest. Not too hard, right? See how it feels like it's repeating a little bit? The only thing that might have been a little bit wonky was that APR one where we had to go find the basic rate. So we had a lot of steps in that one. Turn the page and we'll talk about adjusted balance method, and then we'll be done. You guys will get out early. So adjusted balance is just that. You're going to adjust it by subtracting a payment. So it says interest is calculated on the previous month's balance minus credits or any payments that are made. Credits you could think of as payments that you make. So we would subtract that payment from the previous balance before calculating the interest. So that's going to change what we use for our P value, our principal value. So this one right here, but everything else would be the same. We're still going to use our time as 1 out of 12. So it says calculate the interest on that same $800 credit card bill, the same rate. But this time we do care about the payment. Because in our principal, we're going to say the balance was $80 or $800, but we're going to subtract 30. So now your balance is what? $770. So this is the amount we use now for our principal because we're saying we adjusted the balance before we figured the interest. So our rate is still 0.19 and our time is still 1 out of 12. So our interest equals that 770. Times 0.19 times 1 out of 12. Or 1 over 12. I don't know why it is out of 12, but 1 month out of 12 months. Maybe that's why I keep saying that. So the interest in this one would be $12.19. So let's compare them. They basically had all the same things other than one was adjusted and one was not. Do you see how you pay just a little bit more interest on the ones without the adjustment? And that's because your balance is higher, right? So if you have a higher balance, you're gonna create more interest. That's why if you ever listen to Dave Ramsey, he says, if you have any credit cards out, that should be your goal, is to knock those out as fast as you can, because the more you can knock that principal down, the less interest you're paying over time. And like, I'm not a financial advisor, but I'll just say from my experience, they can get you in trouble because it does just accumulate so much. But there are healthy ways and smart ways to handle credit cards, but I'm not telling you you can't, because I'm not your boss, right? I use them too sometimes, but I pay them all. All right, have a good day, guys. Don't forget your 7-1 and 7-2 is due tonight. Sound good?
I have a question.
Yes.